Okay, so let's pick up on D, right? Okay, so let's go from the very beginning. So here we have cotangent of 5 pi over 3. I take 5 pi over 3, and now that's, 5/3 pi, which is 1 2/3 pi. And it's very important that we know where that lands. So that's 1 pi. And then I need to go another 2/3 pi. So what you have to ask yourself is, do I pass the half mark or do I not pass that half mark? So do I or do I not? I do, because 2/3 is greater than a half. So I go here. Okay, so now what that does is tell me which quadrant this lands in. Okay, next I need to find what the reference angle is. So what's the reference angle here? Pi over 3. I knew that before I even drew, right? So I need to do cotangent of pi over 3. Now, you don't have to draw a triangle here, okay? Just know this. If this angle is pi over 3, is that the big angle or the small angle? The big angle. It means, does it face the big side or the small side? Big side. So is this vertical side, what's the length of the vertical side then? Root 3 over 2. So now, I need to do cotangent. What's cotangent? Adjacent over opposite, right? Or cosine over sine. So adjacent over opposite, right? So that's going to be 1/2 over root 3 over 2.
Where's the 1/2?
It's 1/2. So that you have to watch the screencast from yesterday. Okay? So 1/2 over root 3 over 2. And now, so that's 1/2 times 2 over root 3. 1 over root 3. Now, in this quadrant, is cotangent positive or negative? So now, what's cotangent like? It's like the sine, right? It's the reciprocal, it's the tangent. Cotangent is the reciprocal of tangent, right? So you have to go with the tangent. Is tangent positive or negative here? All students take calculus. So what about tangent? Negative. So cotangent of 5 pi over 3 is negative 1 over root 3. Yeah. Okay. All right, let's do one more. Secant of 120. What's the reference angle for 120? 60. Okay. So 120 is here. Secant, right? I need the secant. Okay, so if the reference angle is 60, is that which side is that? How much is that? That vertical side. Right, which is rad 3 over 2. So this is 1/2. All right. Now, what is secant? It's the reciprocal of the which one? The cosine, right? It's the reciprocal of the cosine. Here, where is the cosine? Vertical or horizontal? Where is the cosine? Vertical or horizontal? Horizontal. So remember what we said yesterday, that y is always sine. So vertical is always sine. So this is the cosine. That means secant is what? 2 over 1. Okay? Now, secant goes with cosine. Is cosine positive or negative here?
Negative.
Negative. So secant of 120 is negative 2. All right. So why don't we put this triangle on the board? Go ahead and I'll put this triangle on. Where is negative 3 pi over 4? It's in quadrant what? 3. What's the reference angle? Thank you. And now, okay, so if it's pi over 4 here, what do I know about the sides? They're both root 2 over 2, right? So now, if I want cosecant, what am I supposed to do? 1 over the sine. So what's the vertical side here? Root 2 over 2. So cosecant is 2 over root 2, right? That's the reciprocal. Okay, which of course is 2 root 2, right? I need to do root 2, so 2 root 2 over 2, which is root 2. Now, cosecant is like sine, okay? Is it positive or negative here? All students take negative. So negative root 2. Okay, now let's do one more. Cosine of 480. Okay, where is 480? You'll realize in the end that it's easier with the radians than it is with the degrees actually, because it's like with the 480 you have to calculate and whatever. So where is 480? I start here, I go 360, and then how much more do I go? 120, so here. What's the reference angle? 60. Okay, so now, is cosine horizontal or vertical side? Horizontal side. Now, here's how I do it. I don't draw those lines. Cosine is the horizontal side. Now, this is the big angle. It faces the big side. This must be the little side. So how much would that be? 1/2. So cosine of that is 1/2. Now I need to do the positive or negative. In that quadrant, is cosine positive or negative? Negative. I put a minus and I'm done. All right? Should we do one more? Okay. So this is the big angle, 60 versus the 30. This is the bigger angle. It faces the bigger side. So bigger angle gets bigger vertical. Okay? That means that by elimination, that leaves the little one here. Okay? All right, I have sine of negative 3 pi over 4. Where did we say negative 3 pi over 4 was? Right there. So what's the reference angle? Pi over 4, right? Okay, what do I know about the sides for the pi over 4? They're the same, so it's always going to be root 2 over 2. Now the question is positive or negative there? Negative. Okay? Now, what you're going to do is, Adam, oh, do we have a... Okay, so here's where we got with our partners, right? Any questions? Anyone needs to be clarified? Okay, what we're going to do now is we're sort of going to go back. I'm sorry I keep switching back and forth on you guys, but I never, remember we skipped this? Let's go back because I wanted to do what we just did before we did this. So let's go back. It looks like this is page 14, okay? And here, now, okay, so we did all the special angles right now. We did the pi over 3, pi over 6, and pi over 4, but now we're going to do the angles on the axes, all right? Now, we said that this is quadrant 1, 2, 3, 4, right? Now, the quadrants are divided by the axes, right? Like the x-axis divides here, the y-axis divides there. The angles here on the x and y axes are called quadrantal angles. Okay? So let's put those in degrees. So this is 0, 90, 180, 270, and 360. Right? And how much were they in pi? I'm sorry, in radian. So this one here, how much is it in radian? 0. And the 90 will be how much? Pi over 2. And the 180 is pi. And here we have 3 pi over 2 and then 2 pi. Now, if this is a unit circle, what did we say a unit circle was? It's a circle with a what? A radius of 1, right? So, if this has a radius of 1, what's the distance of that green line? 1. So, what is the coordinate of that point? 1, 0. Are we in agreement with that? Yeah? Okay. So then what's the coordinate at the 90? 0, 1. What's the coordinate at the 180? Negative 1, 0. What's the coordinate here? 0 and negative 1. Is this anything unusual, eccentric, out of the blue? Like, no, right? Anything that, like, it's we know where this came from, right? Now, we're going to do the trig values, okay, of these with the exact same method. Remember what we've always been saying. If you've got a coordinate point, this is, what does the x value represent as far as trig functions? The cosine, and this, the sine. Okay? So, here we are at 0 degrees and 0 radian. All right? I want the sine of it. So I say to myself, oh, 0 degrees is here. The coordinates are 1, 0. So the sine is how much? 0. Is there any math here? Are there any calculations? Absolutely none. All right? So what's the cosine of 0 then? 1. You just look at the coordinate. The x value is the cosine. Okay, what's the tangent then? It's what over what?
Sine over cosine.
It's sine over cosine. So it's 0 over 1, which is 0. You don't have to show me the 0 over 1. You have to show me the 0. Okay? What's the cosecant?
No, it's undefined.
Okay, the cosecant is 1 over sine of theta, which is 1 over 0, undefined. What's the secant? That's 1 over cosine. 1 over what? What's the cosine there? 1. 1. Okay? Cosine is the x-coordinate, sine is the y-coordinate. What's the cotangent? Cosine over sine. So 1 over 0, undefined. Okay? So my values here are just negative 1. What's the cosine? 0. I just look at the x-coordinate and it's 0. Tangent, negative 1 over 0, which is undefined. Okay? Cosecant is 1 over the sine, which is how much? Negative 1. Secant is 1 over this number, undefined. Cotangent, how much? 0 over -1, which is 0. So if I ask you this, okay, so whether it's homework, quiz, test, whatever, if you write 0 over -1, it's half credit, and then you have to also say it's 0. If you write 0 from the beginning, then it's fine, all right? Here, same situation. If you write 1 over 0, that's half credit. But if you just write undefined, you're good enough. I must see the final result because I need to know that you know. All right, I'm going to give you guys 60 seconds with your partners to do the 90 and the 180. On your mark, get set, go. Big idea. Big idea. You're never going to be given a chart like this to fill out. I'll just tell you, okay, like what's cosine of what's cosine of pi, what's cotangent of 2 pi, what's whatever, right? So just know that what are the possible values that you're going to get?
1, -1, 0, or
1, -1, 0, or undefined. If you get anything else, there is something that went wrong. Okay? All right. So, all right, let's do, I'm still skipping. We're going to go and do this. Angles not on the unit circle. You know what? No, I'm going to go back here. Sorry. Okay, we're going to graph this. So what this is here on the x-axis, you've got your angles, 0 degrees. Here you have 0.5 pi, which is half a pi, pi over 2, 1 pi, 3 pi over 2, 2 pi, all right? And here you have the values, all right? So, what do I mean by that? So, here, when the angle is 0, right, how much is sine of 0? So what we're going to do for that is we're going to go here, and we're going to say here, when the angle is 0, what was the sine? So what was the coordinate point that goes there? It's 1, 0. So what's the sine of it? 0. All right. So let's sort of go over the key points here. So here I have, I'm gonna write that over here so I don't have to flip back and forth. So here I have, let's see what angles I have. I have 0. I have 0.5 pi, which is half a pi. What's that one in the middle? Huh? 45 degrees, which is how much? Or pi over 4. And then here we have 3 pi over 4, 5 pi over 4, 7 pi over 4. So now we've got these coordinates here. At the pi over 4, you don't have to flip back and forth. I'm just going to do it to show you. At the pi over 4, what is my coordinate? So it's what and what?
rad 2 over 2.
It's rad 2 over 2 and rad 2 over 2. How much is rad 2 over 2 if you put it on the calculator? Root 2 is 1.4, and half of that is 0.7. We're just going to round to 0.7, 0.7. So what is it here then? Negative 0.7 and 0.7. Here, negative and negative. And then positive 0.7 and negative 0.7. So let's put those points on our graph here. When the angle is 0, how much is the sine? 0. When the angle is pi over 4, how much is the sine? 0.7. That's somewhere around there. At pi over 2, how much is the sine? How much? 1. At 3 pi over 4, the sine is 0.7. At pi, how much is the sine? 0. At 5 pi over 4, negative 0.7. At 3 pi over 2, negative 1. Then negative 0.7, and then 0. Look at that beautiful, beautiful sine curve. So now, if I do this, look at what that looks like. Is that or is that not the most beautiful graph you've ever seen in your life? I think it is. Okay? Seriously though, come on, you can admit it. This is a safe space. Okay? What do I need you to take from this? When the angle is 0, what's the y value of the sine? What's the y value when the angle is 0? 0. So, starts at y equals 0. Then where does it go? Up or down? Up. Goes up to a maximum of how much? 1. Then it hits what point? 0. Then minimum of negative 1, and then back to 0. How many points did I put here? 1, 2, 3, 4, 5. These are the 5 critical points. And I need you to know for next time or for the rest of your life that the sine function starts at 0, 1, 0, negative 1, 0. Okay? It's consistent with that chart we just filled out. Your values are either going to be 1, negative 1, or 0. We can't get it undefined on the graph, okay? For the sine or cosine. Sine or cosine was never undefined, remember? Okay, so that's sine. Let's do the same thing with the cosine. But you know what? For the cosine, you're going to do it with your partners. Now, instead of taking the y coordinate, you're going to take which coordinate? The x coordinate. On your mark, get set, go. You have 60 seconds. Put your points for the cosine. Even though, you know, it looks like it's a U shape, it will remind you of a parabola. It is not a parabola. That's why I didn't want you guys to draw the line. The way it'll look is it's got a little bit of a curvature like this. Sorry. Like this. Okay? That's how it'll look. Because you have to imagine this will continue to form another part of a wave. You see that? It's a continuation of a wave. So we're not going to do that part just now yet. So now we're going to go and we're going to look at our 5 critical points. And those are this, 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 and this. So let's see what happens. The cosine starts at y equals what? 1. Then it crosses 0. Then goes to the minimum of negative 1. Crosses 0. Then to the maximum back of positive 1. So look at your y values. They go from, they oscillate. Oscillate means they go back and forth between 1, 0, negative 1. They go back and forth with the sign between 1, 0, negative 1. Okay? If we looked at that chart that we made, our values go back and forth between 1, 0, negative 1. Isn't that a thing of beauty right there? Okay? This is what I need you to take with you. That with the sine and the cosine, okay, you need to know where one starts, and you need to know that it goes between, back and forth between 1 and negative 1, because that's what we're going to build on first thing Monday. Okay? Now, one last thing we're going to do. Angles that are not on the unit circle. Okay, so if I have a circle if I have some random angle that's not on the unit circle, right? So suppose I have an angle that looks like this. Where is that reference angle that we all love so much? That's right there, right? Now, if I were to draw a triangle there, because that's just what we do, right? Okay. Is the vertical side the sine or the cosine? Always. What is it? Sine. Okay, so sine and cosine and so on. So now here is what we do. If it's a random angle, all right, not on the unit circle. So for example, you have a point at 6 comma negative 2. Do you guys have parentheses in yours? Okay, good. So you have an angle at 6 comma negative 2. What this is this. Let's draw this. Where is 6 and negative 2? Here. Okay? This is what this looks like. So, how much, if this is the point 6 comma negative 2, how much is that horizontal line? 6. And how much is the vertical line? It's got a length of 2. Yes, it's at negative 2, but it's got a length of 2. Now, is there any way I could calculate that this black, the radius, we call it radius. How can I calculate it? Pythagorean theorem. It's our favorite theorem in the world. So, r squared is equal to 6 squared plus 2 squared. Does it matter if I do negative or positive 2 squared? No, because I'm squaring it. So, r squared is equal to 36 plus 4, 40. R is root 40, which is how much? 2 rad how much? Or 4 root 5? No. 2 rad 10. I'm sorry, yeah. Okay. So that's my radius. Okay? Now, the angle is always this. Because this is not unit circle, I have to do SOHCAHTOA. All right? Because my radius, is my radius 1? No. Then I have to do SOHCAHTOA. So now I have to do sine of theta, right, is opposite over hypotenuse, right? But now, I'm going to label these X and Y, right? So sine of theta is the opposite, the negative 2, the Y over the R. Okay? So that's negative 2 over 6. Does that make sense? That it's opposite over hypotenuse? Y over R? Right? So the thing is, I don't even have to look at the diagram. I just go with this. Yeah. Oh, I'm sorry. It's 2 root 10. I'm so sorry. Oh, I'm so sorry. 2 root 10. So that's negative 1 over root 10. Negative root 10 over 10. Cosine of theta is X over R. 6 over root 10, 2 root 10. 3 over root 10, 3 root 10 over 10. R. Tangent of theta is Y over X, negative 2 over 6, negative 1/3. Now I need to do cosecant of theta. Cosecant of theta is just the reciprocal of this, right? But now look, a little bit of sisterly advice. go to 1 before. Take that step so you don't have to rationalize, and it's just negative root 10. Secant of theta, go to 1 step before, root 10 over 3. And then cotangent of theta is 3, negative 3. Okay, I'm going to do the next one, but a little bit more efficiently. Turns out, I don't really have to draw that diagram, okay? Here's how I do it. This is x, this is y. I need to find my r. So I do r squared is equal to 8 squared plus 15 squared. So that's how much? 289. And when I take a square root, huh? It's 17. Right? Good job. So now, here's what I'm going to do. Okay, so I could do it on the no calculator with the 1 on top, like A. Okay? So, sine of theta is going to be y over r, 15 over 17. Cosine of theta, x over r, negative 8 over 17. No diagram needed. Tangent of theta, y over x, negative 15 over 8. Cosecant of theta, reciprocal. Secant of theta, reciprocal. Cotangent, reciprocal. And with that, we have a handout here.